Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello future engineers, here is another video in Engineers in Progress, particularly in uniform motion problems. If you want to anticipate the solution to this problem, you may do so by pausing the video. Two persons, Arlo and Benz, travel around a 200-meter diameter circular track with time difference of 12 seconds. Arlo is the faster of the two and it only requires him 180 seconds to completely round the track. Assume that both persons follow the same path with constant speeds. How long will it take them to be together for the following situations? Part A, if both start at the same point. Part B, if Arlo gives Benz a head start of 6 seconds. Part C, if Benz gives Arlo a head start of 6 seconds. And D, if Arlo gives Benz a head start of 30 meters. And E, if Benz gives Arlo a head start of 30 meters. So this is the situation. Let us say this is the starting point of the first person and starting point of the second person. So in general, they are not starting at the same time, but if we have a situation here, if they start at the same point, then imagine that the starting point of the second person is also the starting point of the first person. The faster is Arlo, so if we call C as the circumference of the circular track, then it is equal to pi times diameter, pi times 200, so 200 pi meters. The speed of Arlo, therefore, the faster runner, is distance over time, so C over 200, C over 180. So speed of Arlo is C over 180. And take note, C is 200 pi, but we'll just denote it with C here. Speed of Benz, therefore, is C over 180 plus 12, so 192. So for part A, since both start at the same point, we imagine that the slower runner, Benz, is ahead by, is given a head start of one circumference. So C, so the distance of Benz is speed of Benz times time of Arlo, which is also time of Benz actually, but we refer it to time of Arlo. T sub A, it is also equal to T sub B, which is equal to T. Anyway, they will meet at the same time also. So we'll just call it TA in particular, but equal to T sub B in general equal to T. So distance of Arlo is speed of Arlo C over 180 times T time of Arlo, while distance of Benz, so that they will meet at for the first time, is speed of Benz C over 192 times time of Arlo plus C. So C over 180 times time of Arlo equals C over 192 time of Arlo plus C. So take note that time of Arlo is also time of Benz. You may also call this with T, but I'll just denote it with T sub A to be specific that's the time that Arlo should travel, which is actually time of Benz should travel, or it is also the time that uh, Benz should travel before they meet for the first time. So cancel out C, TA over 180 minus TA over 192, that would be TA over 2880, and it is equal to 1 because after we cancel out C, this is 1. So T sub A is equal to T sub B equals T equals 2880 seconds. For the second part, Arlo gives Benz a head start of 6 seconds. So this distance is speed of Benz C over 192 times 6 seconds. So therefore, speed of Benz should be here. Sorry, Arlo should be here. Benz is in starting point 2. So distance of Arlo would be speed of Arlo C over 180 times time of Arlo, while distance of Benz is speed of Benz C over 192 times time of Arlo, then plus C over 192 times 6. So the equation for part B is C over 180 times time of Arlo equals C over 192 time of Arlo plus C over 192 times 6. Again, we can cancel out C. So TA over 180 minus TA over 192 is again TA over 2880, and 6 over 192 is equal to, so TA over 2880 equals 1 over 32 after we simplify the right side. So TA is equal to T sub B equals T equals 90 seconds. For part C, Benz gives Arlo a head start of 6 seconds. So this is now Benz, this is Arlo, and this distance where Benz gives a head start of 6 seconds to Arlo would be C over 180. This is speed of Arlo times 6 seconds. So replace that by C over 180 times 6 seconds. But remember, this is Benz and this is Arlo. They run in that direction. So obviously, Benz cannot overtake Arlo. So let's analyze it the other way. This is the starting point of Arlo. This is the starting point of Benz because Arlo runs faster than Benz. So it's like Arlo gives a head start of this much, but much to Benz. And this distance is C over 180 times 174, where 174 is 180 minus 6 seconds. So this is C over 180 times 174. Again, 174 seconds is 180 minus 6 seconds. And we analyze it as if it is Arlo that gives Benz, this is the position of Benz, a head start of 174 seconds. So therefore, distance of Arlo is speed of Arlo C over 180 times time of Arlo equals distance of Benz would be speed of Benz C over 192 times time of Arlo plus C over 180 times 174. So C over 180 times time of Benz rather, which is the same as time of Arlo, equals C over 192 times time of Benz plus this head start, C over 180 times 174. So cancel out C, 1 over 180 minus 1 over 192 is T sub B over 2880, and the right side is 29 over 30. Solving for T sub B, which is equal to T sub A, which is equal to T in general, 2784 seconds. Part D, if Arlo gives a head start of 30 meters, if Arlo gives Benz a head start of 30 meters, so we have here another figure. This is Arlo, this is Benz, and Arlo is the faster runner. This distance, therefore, is speed of Benz times time supposedly, but this is 30 meters. So 30 over 200 pi, ratio of 30 meters to 200 pi, the circumference times c, it is the same because c is equal to 200 pi, and it is 3c over 20 pi in terms of c. So in terms of the circumference, this is equal to 3c over 200 pi. If that is 3c over 20 pi. If this is 3c over 20 pi, then this distance is c minus 3c over 20 pi. So c over 180 times t sub a equals c over 192 t sub a plus 3c over 20 pi. This is distance to be traveled by Benz. This is the distance to be traveled by Arlo, giving Benz a head start of 30 meters. So again, this is C over T sub A over 2880 is equal to 3 over 20 pi. Solving for T sub A is equal to 137.51 seconds. Then for part E, if Benz gives Arlo a head start of 30 meters, so this is the starting point of Benz, this is the starting point of Arlo, and again, since Arlo moves faster than Benz, so analyzing it in this way means we cannot, Arlo cannot overtake, Benz rather cannot overtake Arlo, and so this is Benz, this is the starting point of Arlo rather, this is the starting point of Arlo, and this is Benz. So it's like Benz is ahead by this much, and this distance is C minus 3C over 20 pi. So that's also 3C over 20 pi. This is C minus 3C over 20 pi. So again, the analysis is, it is like Arlo gives Benz a head start of this distance, C minus 3C over 20 pi. And therefore, distance traveled by Arlo is speed of Arlo, C over 180 times time of Benz, because it is to be referred to Benz time, although it's also Arlo's time. In general, it's also T. So C over 180 times T sub B equals distance to be traveled by Benz is C over 192 speed of Benz times time of Benz plus this head start C plus minus 3C over 20 pi. So the equation would be C over 280 times T sub B equals C over 192 T sub B plus C minus 3C over 20 pi. C over 180 T sub B equals C over 192 T sub B plus this head start of Arlo or of Benz rather, C minus 3C over 20 pi. This is the equivalent. The analysis is it's like it is Arlo who gives Benz a head start of this distance C minus 3C over 20 pi. So C over 180 T sub B over C over 192 T sub B equals C minus 3C over 20 pi. Cancel out C and combine this. C over 2,800 T sub B equals 1 minus 3 over 20 pi. Solving for T sub B is equal to 2742.5 seconds. So that's it for this video. I hope that you were able to follow the solutions and the explanations.